we're going to go over surface area of rectangular prisms. Okay, so we have a rectangular prism, and it can sometimes be hard to tell what face is the front face of a rectangular prism because they look really similar. And it technically doesn't matter just because it is rectangular. For other shapes, like a triangular prism, it'll be pretty easy to tell because it'll have that triangle face. But because prisms have rectangles throughout, okay, it's kind of hard to tell which is which. And there's lots of sides to it. And though when we draw it, this is two-dimensional space. There's only 2 dimensions. I'm trying to draw a 3-dimensional object. So we have like a top and a bottom and a left, a right. And then this is technically in front and this is technically behind. So there are 6 sides to this. But again, hard to see. So let's go into a program. We're going to try to figure out to find all the faces. So here's our little program. Okay, so here is our rectangular prism. And you can see that I can maybe call that one of the faces, or I can call the other side the face. What we're going to do is we're going to color them, and so that we can really define what they're all going to be. So what we'll call these 2 the faces, this one and the one on the complete other side, that one. Okay, kind of look like they almost are at the top and the bottom. So let's label that yellow and yellow. Okay, so on my picture over here, the 2 places I've labeled yellow are this, okay? Imagine them like that, called the top and the bottom. So this page is going to get messy, but it'll be nice on the other page, okay? Along with that, let's label our sides. Let's put them as blue, okay? So we'll call that blue, blue. Actually, I don't want that to be blue. Those will be our left and our right on the other page, okay? So our left, this is my left. This will be my left one here. So you see there's overlapping when it's in 2D space. There's my left and my left. And then finally, this is our front and our back. Let's do those green. Green and green, okay? So we've now labeled all of them, and you'll see when it's in 3-dimensional space, see this green one? It pretty much goes over everything. So now it's really hard to see what the heck we were talking about before. Green and green, look what it does. It colors everything in, right?
I don't think that's that weird.
That one? Okay. So that doesn't really work on this page, but on this page it's really, really nice. So let's take a look at all the faces to this. So when we fold it outwards, okay, we notice we have 6 faces. We have a yellow and yellow for the top and the top. Then we had the left and a right and a front and a back. So we have to find the area of 1, 2, 3, 4, 5, 6 faces. Luckily, the top and the bottom have the same area. The left and the right have the same area, and the front and the back have the same area. So let's go over there again. Let's label them one more time. What are the colors? We had yellow on top, so I'll put that in black. We'll call this a yellow and a yellow. That's the top. We'll call this blue. Left and right were our blues, and then the front and back were green. So this will be my front, and that other one will be my B-A-C-K. Okay, so there's our back. So we got to find the area of every face. So let's give it some value. So I haven't labeled it, but I can count across. There's 1, 2, 3. So this looks like this is a distance of 3. It's hard to tell depth, so I'm going to say it's 2 centimeters. This will be 3 centimeters, and it goes up 1, 2, 3, 4. 4 centimeters, okay? So I just measured it using the unit bricks on the side. Okay, so we have this now. So we got to calculate every face. So we have to decide which faces to use. So maybe let's start with the 2 yellow ones, okay? So the top and the bottom. So this very top here, okay, we got to figure out what this length and this length are. And according to our numbers, what are they?
They're 4.
And this one. So it's all the way across here. And we can tell by looking at the bottom. How wide was it? This would be like our width here. Or you know what we can even do? We can look at the bottom one. The bottom one is the exact same. Remember, it's yellow. So this is 3 centimeters long and 2 centimeters in depth, okay? So we'll call it yellow, okay? So we'll say the 2 yellow faces are equal to 3 times 2. Each of the yellow faces is 3 times 2. So we know they are 6 centimeters squared, and I won't put the 2 there yet because we've only technically done one of them. Now, the whole bottom is 6 centimeters, but what if we do the bottom and the top together?
Then it would be 6 centimeters times 2.
That's right. So we'll say the 2 yellows are equal to 6 times 2. Okay, and maybe it'd be better if we called it the top and the bottom of it. But that's going to be a total of 12 centimeters, okay, squared. So we've got that. Those were our two yellows in our other page. So that we figured out that these two yellows, each one was 6, altogether is 12. How about the blue one on the side? Okay, this is our blue one. Okay, we know the bottom is 2. We got that. How high up does it go?
4 centimeters.
4, that's right. So we'll say our blue. Our blue is 2, because they're all rectangles, 2 times 4. It's all centimeters. So 2 times 4 is 8. It's 8 centimeters squared. But how many blues are there? There's 1, 2. All right, so we do the same thing again. We have to multiply that blue times 2. So now we have 8 times 2, because there's 2 of them. And that's going to be what? A total of
16.
16 centimeters squared. Okay, so I'm just going to highlight our answers as we go through. So we have 12 centimeters squared, 16 centimeters squared, and that was the two blue faces. That was this one and this one. We figured out they were 2 by 4. And finally, we got to do, the front and the back. Okay, so our front. We know our front is this wide. How high up and down does it go?
4 centimeters.
4. So it's 3 by 4. So we'll say that one's in green, right? I think that was the color we were using. So green is equal to 3 times 4. So that's equal to 12 centimeters squared. And what about, there are 2 of them, right? So 2 times green, so that's going to be 12 times 2 gives us what?
24 centimeters squared.
24 centimeters squared. So let's highlight that last one. What colors do we use? Blue, green, blue. Let's use a yellow one. Final answer. Okay, so we've got the 3 different types of faces, right? We just did the 2 green ones. Whoops, turn that green again. We just did those 2. We did the 2 yellows, and we did the 2 blues. So we've done every face. So really, surface area of a rectangular prism is equal to the front times 2, right? Because you could say it's the front, so you could say there are 6 sides in total, and we could say it's the 2 times the front plus 2 times the top plus 2 times the right or left. It doesn't matter, left. Okay. Now our front was in our green color, I think down here. I should have kept it. Our front was green, so we figured out that the 2 front faces were equal to 24. Okay. Plus, what are our tops? Our tops were the yellows, right? So I'll write those in black. The 2 tops, we figured out all together were equal to 12. So we add 12 to it. And then finally, the left and the right were the ones we did in blue. Okay. Was equal to 16. So we added to 16. Okay. Does this make sense how we built this all together?
Yes.
Yeah? Okay. So we've got them all, and sometimes it takes a bit of breaking everything up, left, right, and all those things. So now we just got to add all of our sides together. It's still going to be squared, whatever our answer is. And I'll tell you, 24 and 16 is going to be 40, and 40 and 12 is going to be 52. So this is 52 centimeters squared. That's the total surface area of the shape. Okay. Now on this side it might be a little confusing, but remember, this is how we really broke it up. We had all of our shapes. There we go. We had all our shapes together. Can I do that? There he is. And you can kind of see them all as we spin them around. So remember, you can make nets of all of these things, which makes things much easier to look at. Okay. So there's our surface area of our shape.